Here we look at the laboratory preparation of oxygen gas. Oxygen is an element, of course. It has the formula O2, described as a diatomic molecule. It consists of molecules in which we have two oxygen atoms joined together. I'm going to form oxygen from a chemical called hydrogen peroxide that has a formula that would remind you of water. The formula of water is H2O, and the chemical I'm using here, hydrogen peroxide, has a formula H2O2. Here is what hydrogen peroxide looks like. You can see it looks simply like water. It's a colourless, clear liquid. And this liquid here very, very slowly decomposes to produce two products, water and oxygen gas. In the presence of this black powder, things change. The hydrogen peroxide breaks down very fast. What do we call a chemical that speeds up a chemical reaction, but when the reaction is finished it's still there and indeed can be used over and over again? It's a catalyst. So this black powder, called manganese dioxide, also known as manganese 4 oxide, acts as a catalyst and speeds up the reaction. Now, here's the setup that I'm going to use. This is my reaction flask, in which I've already put some water, and I'll explain the reason in a moment. So I've got water up to here at the moment. And I'm going to collect the gas oxygen by downward displacement of water. The density of oxygen is very similar to that of air, so we cannot collect it by downward displacement of air, like we did for hydrogen, and we cannot collect it by upward displacement of air, like we did for carbon dioxide. The only method available to us is to collect it by this method. The gas will be formed in the reaction flask, travel out through the side arm here, through a delivery tube which will connect up here and go through the water in the water trough, under the beehive shelf, and up into a gas jar filled with water. And as the oxygen rises to the top, it will displace the water downwards. Here's my water trough, and you'll recall what the beehive shelf looks like. The gas delivery tube goes in through the side here, and the gas comes out through the top. It's important that the beehive shelf is completely immersed in water. Now I'm going to fill my gas jar to the top with water. It's filled right up to the top. And I take a glass disc, see here, I put that over the top. That will allow me now to turn the gas jar upside down. I'm going to place it under the water in the water trough and carefully up on top of the beehive shelf. Here's my reaction flask. I've already got some water in here, as I said, and my delivery tube. I'm not going to put the delivery tube under the beehive shelf just yet. Now I have my catalyst, manganese dioxide. I'm using a funnel made from paper. I'll add that to the glass. So there's my manganese dioxide catalyst is there, and it's present in some water. The only thing that's missing is the hydrogen peroxide itself. I'm going to put the bung with the thistle funnel inside, and the thistle funnel is immersed completely, so the gas cannot come out through the thistle funnel. Now the reason that I put the water in here to begin with is this reaction, if the oxygen is produced too fast, it can actually cause the bung here to explode outwards, and since it's got the glass funnel here, the thistle funnel, that would be extremely dangerous. I find it safer if I add the hydrogen peroxide in small amounts and collect the gas. Now the first gas to come out will not be oxygen, it will be air that is displaced by the hydrogen peroxide going in. So at this stage the delivery tube is not under the thistle funnel. So here we go, I'm going to add a little bit of the hydrogen peroxide. The bubbling at this stage is just air coming out. And now what's coming out is oxygen. And I keep a close eye here. I always keep a close eye here to see what's happening. If there's any big build-up of pressure, I would take the bung out to release that pressure, to ensure that the bung here doesn't explode upwards. I can see here that the gas being collected is colourless, clear gas. That's oxygen. And there I have safely collected a gas jar of oxygen. So I can remove that and put the glass disc on there. I can turn it up right. Just remove this. Now, you recall the test for oxygen. If I take a lighted splint, what do we do next? So we extinguish the splint, so we have it glowing. Hopefully you can see that it's still glowing there. I take the glowing splint and put it inside, and it relights. In fact, it'll do this a number of times. The glowing splint relights in oxygen. So there you've seen the production of oxygen from the decomposition of hydrogen peroxide using a catalyst, manganese dioxide.